All right. Tell me how to start. How to even start doing such things in .NET World.
Well, contrary to what Stace just said about not trying all the new shiny things, this is new shiny stuff. So .NET 6 came out in November. It's an LTS, a long-term support version. And we got a couple of things. Oh my God, Thindle, go away. We got top-level statements. I'm going to show you these in a minute. And this takes away a lot of the ceremony of just the normal way of getting started with apps that are working in C# or with Java. There's an awful lot of ceremony, and this has simplified it down. And we also have minimal APIs, which is another way of simplifying it. And both of these things are an attempt to make C# more welcoming to developers from other platforms. So if anyone has ever done any Node development, this is going to look kind of familiar. This minimal APIs is going to be in a similar format to that. So we can have a look at those. So I'm going to flip over to my screen. You do it. You're in control. You're in control. Fight. So if you are familiar with C# applications prior to .NET 6, this is going to look very alien. You would have had a program with an entry point through a main method, and you most likely would have had a startup class as well.
So this is the top-level statement, right? That one.
This is the top-level statement up here. So this has been made a static method now, and we call the builder, which is a web application builder. If I hover over that, that's what we're doing. This can still be broken back out into what you're more familiar with a main method and a startup class, but we're going to roll with this.
All right.
So we have that, and now we can add everything that we would normally do in a startup class to this builder. And we're going to come back to all of this stuff down here, but this is our normal sort of services that we're adding. We've got controller support. We're going to have Swagger in here so we can test our endpoints. And then if I come down here, we're building out our app, and this is now our web application. And then we do all the stuff that we would normally do in our startup again, middleware that we're adding in, our default controller mappings. And then down here, this is a minimal API.
Nice.
So you can see, if you are familiar with Node, how this looks very, very similar, very familiar. I have my root here, and if we go along, we've got what this is going to return. And I actually go and get a service, and we'll talk more about services in a bit, but I can go and get that from a service provider and use that in here. And if I run this...
So there is no class, right? I don't see any class. Where's the boilerplate? Where's the boilerplate?
It's all gone. It's all gone. It's brilliant. None of that. Straight in. And I was a little bit skeptical at first, but now I'm fully on board. And here you can see this is our minimal API. And then the ones down here are from our traditional controller. And we're going to have a look at that in a little bit. But you can see that Swagger is separating them out. And I can go and try this out. And you can see I've got all my ingredients and stuff just as I laid out in here. I just created an anonymous object and I've got it. So that's kind of some of the new features of ASP.NET.
Nice. I like it. Nice. Well, I have a question, because I'm used to having like an IOC container to which I inject some dependencies so that they can be later on used in the different places. Where's the IOC container?
Alrighty. So what we have is, if I come back up here, I'm going to make it bigger. My famous saying, bigger. I have my IOC container here, my iService collection, and I am adding my services in here. Now, I could add a transient or a scoped lifetime service as well, depending on what you want, but everything here is being added as a service to our IOC container. So that's what is going on here.
Okay, so the IOC container, correct me if I'm wrong, but doesn't require any external library. It's built into the platform, right? The IOC container itself.
It is completely built in. It's part of .NET Framework. We don't need anything external to this. And this came in with .NET Core, because prior to that, when we had .NET Framework, we had to use like Castle Windsor. What else did we have? Ninject. There were all of these dependency injection management libraries that we had to use. But now it's just part of .NET. It comes straight out of the box. And it's really good. I think it's a really good container. It's really easy to use and easy to implement.
But I see an issue, because I want to go back to this top-level statement. What happens if that file, gets messy? For instance, I have multiple business modules like this. We are building waffle companies, and I have marketing module, production modules, and the waffles research module, and I want them isolated. I want the configuration when it comes to dependencies isolated as well.
All right, we can totally do that, and it's good practice. So if we hop back over to the code, you can see here, I've just got this, and you're quite right. If I had 20, 30 dependencies, this program file is going to get really, really blah. So I've prepared one earlier. If I come down, commented that out, and I've got this add dependencies. And this is some code that I have written. If we head into it, this is going to be an extension method of iService collection. Now, I have put this in a partial class. There's no need to do that. You don't have to. This could be a class. This can be called anything that makes sense to you. I just happen to have called it iService collection extensions, and it's in a partial class. So if we come down and have a look, to extend iService collection or anything really, you have to have it static, and then you have to use this keyword here and return the services. And you can see I've just brought those services back in here.
All right.
So this could get pretty big as well. So another thing that you could do, either in a separate file or in here, if I just copy this, let's come down here. I'm going to make this one private because it's only going to be used in here. And I need that here. This is going to be, you had marketing dependencies. So let's go marketing dependencies. And then I have to return services again. And now I can use that one in here. So let's actually add this. And because we've passed in services, I can just write services.add singleton. And this time I'm going to add a private, marketing private dependency. And then I'm going to add just another one in here. And this one's just going to be, I think we have marketing endpoints. Now, to use that, I can
There's a typo, line 21, 21st.
Okay, I'll fix that in a moment. Services, it's probably brackets.
Yep.
Dot add. There we go. So, line 21.
All right.
There's no typo. Where is it? Where did you see it?
No,
Is it gone? I fixed it.
Thanks to my help. And the name of the class, is that a convention or is that necessary?
Not at all. No, this could be.
Can I call it like marketing dependencies or research dependencies? That's so much better than Jakub's classes. But okay, the system works.
That's it. But it could be whatever you like. There is no convention on this particular thing. Okay. There are conventions, but we can cover that later.
Okay.
But this one, yeah, and I say this doesn't need to be partial. You could have, this could be marketing dependencies in another file, whatever suits your code base.
So it allows me to isolate configurations, and I can have like one file per business model.
Yeah.
Nice and tidy. All right, cool. Which brings me to my next question, because you touched this marketing private dependency. I like my code, at least I think that I like my code tidy. I like to think about myself in that way. When I have 3 different business models, probably I would like only the public facade, or so to say, the endpoints to be accessible by the container. Can I have private dependencies just for the sake of each model?
So yes, but there's a big caveat here.
Mhm.
When you first asked me about this, I went to that great resource that's Twitter, and Steve Collins, who's probably in the chat or was this morning, Steve Talks Code, pointed me to his blogs and John Hinton's blogs on how you have to be careful about this. And I actually learned that the IOC container doesn't manage everything. Okay, so if we go back to the code, the IOC container is managing the garbage collection of these right now.
All right.
Okay, but you want to make this private. So let's do that. If I go var, what was it? Marketing privacy dependence. Best name ever, wasn't it?
Yes, I like it.
So clear and concise. And now I've got that. Now I want to, I'm not going to add this. You see, it's Visual Studio saying, oh, add it as a singleton. No, because
that would be global, right?
Yep, that would still be global. So now what I have to do is come and edit this one. And now I'm going to go new marketing endpoints. And I'm actually going to instantiate that here with its dependency, because I happen to know that this is a dependency. So there are gotchas. If this calls iDisposable, this is now not going to get managed, and I would have to manually go in and call iDisposable. If this doesn't have anything to dispose of, this is fine. And I believe a way of getting the IOC container to manage this would be to actually use this expression, and this is our iService provider context. And we're adding it to the service provider this way.
Right.
So it's a slightly different thing. And I believe that is going to now manage the garbage collection for us. It's a way around it, but it's something that you need to be really aware of. And I will share links to Steve Collins's blogs afterwards. He's so knowledgeable on all of this stuff. So thank you to him for helping me with this.
All right. So there is a way.
Yes.
I have a next question.
Come on then.
It's gonna be easy, probably, because I've seen this convention in C# that you like your interfaces to start with I, like it makes sense, right? I waffle creation service. And then I have implementation waffle creation service. Of course, that makes sense, right? And let's say I have another implementation, another waffle creation service. They both implement the same interface. And now I would like to register them in the IoT container so that later on I can inject a concrete implementation. It's not a common use case maybe, but even though it happens, can I do that?
Yes. That's it. Yes, you can.
Next question.
All right, let's go and have a look at this. So let's isolate this line here. Right now, what this line 12 is doing is I have an implementation of iWaffle creation service called waffle creation. So when a service asks for iWaffle creation service, it's going to get this implementation. Okay, and that's quite a common thing that we do in C#. It's not always necessary. And if we come to see how that looks, you can see I have my private iWaffle creation service, and then I'm injecting an iWaffle creation service, and I know that that is now going to give me that implementation.
All right.
That seems pretty straightforward. I can't ask for a waffle creation service because that hasn't been implemented. Okay, I haven't added waffle creation service. I've added iWaffle creation service. So the other way I can add stuff, well, let's go and have a look at another implementation. Let's do that one first. So now I have another. I don't want to update PowerToys right now. Thank you. Now I have another implementation. But if I use this code here, how does this know which version to go for? It doesn't, and this is going to break. So now I have a different constructor that I'm going to use. I'm going to do this one down here. Oops. And I'm going to inject a collection of iWaffle creation services. So all of them. We can talk about whether this is a wise use case or not in a minute, but I now inject the service collection, And then I'm going to use a little bit of LINQ, which is language integrated query language. And I'm going to use this expression to go and get the type that matches the one I want, which happens to be waffle creation service. If that's not there, I'm going to throw a new argument. So really, this should be first, not first or default, because I want this to say, if it doesn't find it, I want you to throw an exception.
All right. So there is a way to be completely fair. I would say that if it happens every now and then in your code base, that's probably you smell, right? Architecture smell. Like why would you want a concrete implementation all the time? So why do you have this interface in the first place, right? Does it make sense?
There's a good use for this type of implementation, and that's if you're using rule sets, for example, and you want to iterate over that collection for whatever reason. I always like to use it for notification services, for example, different implementations of different types of notification, and you pick the one that you want. So that would be another way. And there's a third way that we can implement this. If we go back into here, and this would be how, if you needed multiple implementations, I would just add the implementation directly to it, just like I did with this waffle ingredient service up here. So this is also a way to do it if it doesn't implement an interface. As you can see, waffle ingredient service doesn't. And now when I do my controller, I need to request this one specifically. Notice this is the interface, this is the implementation. And this now needs to, well, it doesn't, but I like to change it so that these always match.
All right,
so,
cool.
You know, this is another way of doing it. So you kind of choose what you need to work for you. I'm actually just going to revert back here because, you know, I have code that needs to work later on, and you're going to mess with my code.
Yeah, follow the script, please.
Yeah. It's still going to break. I know it. So if we come back in here as well, I'm just going to revert. There we go. Let's just comment that one out as well. There we go. Back to the status quo.
All right. So that was it when it comes to dependency injection. I've learned that DI is a part of the framework.
Yep.
Which is nice. I know how to do multiple implementations, how to inject them, how to register, how to do private dependencies, how to use any dependency. That's cool, but that was easy, let's say, right?
Yeah.
That's the beginner part. Let's talk about something more concrete.
Okay.
You showed me, I think, next to the waffle creation service, I've seen something about HTTP clients.
Yep.
I guess there are some policies as well. So let's talk about how to do controllers. I've seen the minimal API, but is there any other way of defining routes, endpoints, and to use HTTP clients? Are there any conventions?
There's all of the above. All right. So if we go back to code, the first thing I want to do is just with minimal APIs is come down here, just like the services. If you have all of your APIs in here, that's going to get messy. So just like we've done with other stuff, I can actually go and extract this out. So here, this one happens to be asynchronous, doesn't make any difference. And in here, you can see that I've got my APIs in here, and you can divide that into any old business logic that you want. I'm going to drop a link to Jeff Fritz's instant APIs as well, because that's will automatically generate all of your CRUD endpoints based on your context. That's a really cool feature. Yes. So we've got that one, and we've got these routes here. So that's, you can define these to be whatever you like. But we did spot a controller up here, and this is very convention based. This happens to be an API controller. It has this decorator, which gives you some extra goodness for an API controller. It inherits from controller base, and I can define the route here. Now, this is going to look at what the controller name is, and this one will be API/waffle order, because the framework knows to chop off controller. I don't have to call it. I could be like API. I want this to be my name. It doesn't matter. It can be Layla's API. And you can see if I run that now, it's going to, see here, I knew it was going to break somewhere.
Always.
Always.
Demogat, right?
I know what it is. It's
Maybe let's switch to Java.
go away. It's this one, because I changed it back to, I should have left it where we were and not undone all the good work. There we go. So back in here, if I run it now, I knew it was going to be pesky and break on me. You can see I've got those two minimal APIs, we'll call that. And if I come down here, I've got Layla. Now, this is also an old-fashioned way of doing it with this options on the end. So we're going to change that. And we're going to look at like the more popular way of implementing API controllers now. And that's in a more RESTful way as verbs. So you would take this out, and this is just going to be my get action. I'm going to take this one out. And this is going to be my post action, and I can overload these as well. I can have puts and whatever else verbs you want, but we keep it very much a controller per verb, a controller with a set of verbs and not lots of different named roots. So if I now run this, you can see that I've got rid of that end root. And now it's just a get to this endpoint, a post to this endpoint, which is much nicer. And I'm also going to come in here. You can see I've got this from body decorator. Yeah. So this is telling my action to go and bind this model from whatever is in the body of the post. Okay. And it's going to do that to the best of its ability. And this is really, really good. And if I go back, I've lost it. Here it is. If I actually go and make a post, I happen to know that this is an enum. Let's try it out. So if I come here and I change that to low fat, because I happen to know that's one of the waffle types. Who wants a low fat waffle? It
doesn't make any sense.
It should have ice cream and strawberries and chocolate sauce and
it shouldn't work.
So we can see that it's already hopped on here. If I hover on to the model here, you can see it's done a pretty good job of binding this. It has even, I hope, managed to bind that low-fat enum to the enum value. And that's because if we go and have a look in here, this happens to be a collection of toppings. I have more decorators. This is all the system.text.json. And I have this enum converter, and it's going to go and convert my enums. And if I come, we can look at that. That's just a big old monstrous piece of code about how to convert my enums. So that you can write your custom converters to behave how you like. So that's pretty cool as well. So I'll just let that continue.
Next question that comes to my mind.
Alrighty.
Because so far we've seen just, I would like to say, API-based controllers, you know what I mean? And what happens to good old-fashioned MVC, like view-based controller? Is there something like this?
Yeah. So that is still part of here. Even though this was is mainly like minimal APIs, we had in our program, we still added controllers, hence why we have this waffle order controller. But say I want it to have some views. I can still do that. I can come and add a view. And I'll just call it home controller. And now this has slightly different routing and conventions. You'll notice that it doesn't have any decorators, and it inherits from controller rather than controller base. Controller itself is from controller base, but this now gives us view specific stuff, things like this. Now, this will have a root of whatever your base URL is /home. You can change it, but that's the default mapping. It will chop that off. The index is a special one, and that will be on the root of home. So /home will come here. So if I was to see the root, it would be URL /home would get me here. And I have to have a view to this. And that needs to be in a view folder by convention. Okay, so this now will need a view called index.cshtml. So that's kind of a CS, that uses Razor mixed in with HTML. Now, if I wanted, we call these actions. If I wanted another page, let's say my page, this one is going to be /my page. So the convention makes it like that. And this view would need to be my page. There's one other nice thing about this as well. If I had int ID, there's a convention that would also make that ID. So it doesn't need to be ID, like question mark ID equals whatever it is. It would have this pattern. That's a special case with ID, whether that's string or int, based on this keyword. So that's another nice thing about your views. And that's your views there. And you can do all your logic in here or inject what you need with a constructor, whatever is required.
It is nice indeed. But it shows what I have to do if I'm the application, which is, like, I would like to say, the producer of the API. I'm exposing some sort of API or view, right?
Yeah. What
happens if I want to talk to a different application, let's say via HTTP? And in the code base, I remember there was something like services.add/HTTP client somewhere in there. And probably there are some policies as well. So let's talk about this.
That's a really good thing to cover. HTTP client factory, which is one of your questions, is one of the things that I really like. And you can see here, this is what you're talking about. So I have added a generic client, which makes IHTTP client available. If we look at this ingredient service, you can see, not IHTTP, sorry, just HTTP. This requires it, and I can just add it. Let me close those, like that, okay? Like that even. So let's take that out. And I have another place to go and look at this. So if we look at this code, I've added this back in here. But now this is just my general HTTP client, but I actually have, this one's no longer add singleton. I'm adding this as an HTTP client. And this is using the HTTP client factory, and this happens to be a strongly typed. So I can request this type with its client, and that's what we call a strongly typed. Now, the reason why you want to use HTTP client factory is because it manages all of your HTTP clients. It cycles them, it reuses them, and it will stop things like socket exhaustion. So if you have a really high load system, it's going to prevent horribleness.
So to make sure I got it, the line number 14 gives me generic one.
Yes.
16 gives me so-called strongly typed HTTP client. Am I right?
And we have a third one, which is a named one, which would look like this. So we have services.add HTTP client. Okay. And now instead of a type or just a generic one, I'm going to give this a name. So this is a string name, my client. And then I can actually set this up in here. So I can use an expression to go client. I'm going to pop this onto a new line just so you can see it. Client, and then you can set up loads of different things. I'll just add one property, which is going to be client.base address. And we can add that new URI. And that's going to be whatever that happens to be, okay? And you can add loads of stuff. You can add your headers in here. You can set up your client completely in here. If I wrapped this in curly braces, put that on there, we could go to a new line. And now I can go client.default request headers.add. And then I can add whatever those are,
Quite flexible, I would say. Nice.
Yeah. So we can add that nice and easy like that. So, and that would be named.
Named, generic, and type. Okay. What about those policies or policy candidates? You would try policy. I see circuit breaker. I know what's that. I studied, electric circuits 10 years ago or 12 years. Somewhere around 2008 or something like that. And fallback policies, what kind of policies are that like? Why should I use them?
So these are all policies that come with poly. So Ian, in your session earlier, was talking about poly policies, and this is going to help us make resilient applications. So when something goes wrong with a request in an API, this is telling the service what it should do. Should it keep trying? Should it do something else? And so we add these policies as methods, and we can come down and see all of these. And you can see these ones. There's a great blog on the Twilio blog that went through all of these. There's a series. I can't remember who the author was, but check out the Twilio blog for a whole really nice series on policies with poly. So we can have a retry policy, which is, okay, how many times can I keep trying this API? I think you have a nice diagram for this one, so we'll come back to that one. Oh, you've got it there. Go for it.
Circuit breaker. Yes,
Yep.
I have a diagram. I created it myself. My diagram.
Okay.
So the reason why we might want to use something like a circuit breaker pattern is when you have one service that keeps calling another one, and the other one fails for that 100 times, for instance, probably it won't work if you try one more time. So it doesn't make sense to call and saturate the network. What you do with circuit breaker pattern is that you are going to open the circuit. It's a little bit counterintuitive, at least to me, because when everything works, the circuit is closed, so you can actually communicate, right? When the failure threshold is exceeded, you open the circuit, which means you cannot communicate. Instantly you return an error so that the client doesn't wait, which is good. But you cannot keep it open forever, because maybe the down-performing service is already up. Which means after some delay, you are going to so-called half-open state when you try. Maybe it's up. Maybe if I communicate, it succeeds, right? So if that happens, I go to the closed state and everything is back to normal. Otherwise, I'm back in the open state and I wait for another period of time, the delay, and we retry. This is how it works. A very simple pattern.
Yep, and we can totally implement that in code. So if we have a look at the circuit breaker policy that we have, this is a simplified one. There is another overload where you can specify more things. But if we look at this first one, handled events allowed before breaking. So if I just bring up Jakob's diagram again, that is this failure threshold. Okay, so that's, we're saying we're going to have five tries, and then we're like, right, we are opening this circuit. And then the duration of the break. So again, if we look at the diagram, that's the delay down the bottom. We're going to wait 30 seconds before we try one request. And then if we go to the more advanced one, you can specify different things and other things about that.
Yeah, correct me if I'm wrong, but I could define different policies, including even different circuit breaker for different HTTP clients. Right?
Absolutely. It may not be, I think the recommendation is to have one circuit breaker policy to use across all of them. But as you add them to each client, like typed or named, you could add it to the general one here as well. If you had another get retry policy that needed to be slightly different for something else, maybe it's going to a different external API that needs handling in a different manner, you can totally customize each HTTP client. So complete control just through all of these lovely extension methods. And if I just come down here, there's two ways I've got these in here. One is this extension methods, which gives you a little bit of syntactic sugar, or you can handle everything yourself by using policy straight from Poly. So there's a couple of different ways there to go about it.
Where's the XML or YAML?
YAML is a swear word in my books. Shh.
All right, so no YAML yet. At least there's JSON, right? Some JSON.
There's JSON. There's a little bit of XML, and but no YAML. Thank goodness.
So we talked about HTTP clients, how to configure controllers and routes, API versus view controllers. That was nice. Client factory when it comes to HTTP client. Policies, circuit breakers with Poly. Poly is an external library. Correct me if I'm wrong.
It is.
All right. So I have to somehow import that. It's not
Oh,
built
I
into
can
the
show you
framework.
that. I can show you the XML then. So you may have heard people talking about NuGet, and basically we have a package manager that is here, and you can, these are the ones I have installed. You can browse for more. Oh, look, this is a new project and already I have to update everything. But you can also see what's in here by going to the CS proj, and you can edit things in here. So if I can ever find where that is. This is very cool. Shout out to you, Thindle, in the chat. This is no docs. Thindle, drop a link. You can see it hides everything. Look at it. I'm not going to dox myself, but unless I do this. So you can see all of the package references I've got in here. And the one we were looking at was Poly down here. So you can see that I've brought that in as part of the Microsoft HTTP extensions. So we've got all of that in. And then there's a whole load of other stuff in here as well.
So there is XML, I knew it.
Yes, I said there was a little bit of XML, just no YAML.
That's like 100 lines. Right, let's go back to our main topic. We covered dependency injection. We covered HTTP, right? What about DB? What about DB context, connection to any sort of database? How to define entities, things like that. Is that easy or not?
Depends on your definition of easy.
Without XML or with?
Without. So it's all good. So I know you were in a talk with Julie Lerman yesterday, who is an expert on Entity Framework. So we're going to look at Entity Framework because that is for our sort of relational databases. That's an ORM. And I kind of like to use it. So if we come over here, I'm going to just save these. Let's go back to our program. I better add my clients and policies in. And if you saw, this one was already here. And this is add database. This is another extension that I have written. And then I'm passing in configuration. And if you go up here, I define my configuration up here with all of these extensions. And these extensions tell the configuration to go off and look in JSON files, environment variables, user setting, secrets, all of that. And that can use the I options pattern, which is a topic for another time, but is pretty cool. So if we come down and have a look at the extension method I've written, the only difference here is I include the I configuration as well as the services here. And this is yet another way of adding something to the iService collection. And this one is a special type, and it's add DB context of type, whatever my implementation of DB context is. So I have waffle DB context, and then you can see I'm using the options here, and I'm saying I'm going to use SQL Server in this instance and go and get me that default SQL. So if I come over here and show you in my, I don't know why I right clicked on that. Again, show you all of that. You can see I have my connection string here, and I'm telling it to use this particular connection string, default SQL. You could have lots of in here if you had other types of databases, other connections, it could all be in there. I happen to have it in user secrets. I've told program to go and check there. So I've got that. And then if we go look in my data file here, I have my waffle DB context, which is implementing DB context, okay? So I come down here and I've set my databases, my tables, and I have users.
These are tables, right?
These are all tables. So that's got this special here DB set. And if I just go and look at my lovely clean entities, if I don't press the back button, so clean, so fresh and so clean. You like that? Yeah.
How does it work? Because I suspected there will be something like this on the left side. I have entities decorated with something that gives me the database schema mapping. So I'm not saying it's wrong, but let's say it out loud. It tightly couples my entity config to the entity itself, right? Whereas what you are showing me, I have clean entities, but somewhere the code for DB mapping has to be found, right? So where is that?
Yes. Okay. So I use something called Fluent API, written by Dennis Demon. And if we come up here, where I create my database models, we should say that this is code first. If you had a database already, you could use the entity framework wizard to bring your database schema in, and it would create all your models for you. But I'm doing this code first. So I have all these configurations here. And if we actually go and look at these, this is where I have defined all of my database, like data properties. And I can even go as far as being like, has column name. I can give this another name, electronic mail, whatever, however I want to call that, preferably not with a comma. Nil. Okay, but you get it. I can handle so much.
I got it.
On my data here. So I have all of this in here, and it's now not on my entities, which I really like to keep my entities clean without decorators. I faux shamed C# Fritz a few weeks ago with this. He came into my code and he decorated my entities.
That's so mean. That's so mean.
So then I call them, I also have a seeded database here. So if we go and have a look at my initializer, I've actually got a seed database here. So my initial, if you wanted to migrate some data, you could come and make it all manually like this. You know, it's not easy. It's time consuming and a bit pesky, but it's all there. So that will seed our database.
Speaking of which, how to do and seed in an in-memory database if I want to have something like that for the testing purposes? Because we covered DB first, model first, code first. You've been telling me about Fluent APIs, right? How can keep my entities clean? But another common use case is actual database testing. Without containers, I could do that with containers, of course, but how about in-memory first?
So we can do it in memory. I just saw something about migrations on there. I have my migrations here. So I run data migrations. These are generated from the command line. And you can see I've got my up, and it also generates a down for me somewhere down there, down. So I can apply migrations. So absolutely. And that I do that from the command line using entity framework command line tools. They're great. Too much to go into now, but I love doing all of that. It's really easy to manage your data and make changes to your data, and it will do it all for you. So you were asking about tests. I have a test. Look.
Wonderful.
So if you wanted to use that seed data for in-memory testing, it's pretty straightforward. I'm going to create a DB context options builder and tell it waffle DB context. And here, whereas before we said use SQL, I'm saying use in memory. And this is only designed for testing, okay? Don't use this in production. And then here, we're going to go and get the options from the builder, and I'm going to create that. And I just call this ensure created, which actually instantiates it. And if I come here and run all the tests, I ran that rather than debugged it. Let me go and...
That's better, yes.
Is it done? Yes. Debug all tests. We should see that it will hit this. And if I just step over that and hover, you can see it's got those two tests that I seeded. So I probably should do ensure deleted as well here, but I haven't. But just know that you may want to handle that as well. So yeah, that's how you can use it in memory.
Forgive my ignorance, but is that NUnit, the framework you're using?
It is. So I advocate for NUnit is my of choice. People like XUnit. I like this setup in NUnit. I've just always used NUnit. I like it. And so yeah, I've always used NUnit.
Which one is more popular according to you, at least? Like just fair question.
There's been more of a movement towards XUnit because I think it's more regularly maintained. But the NUnit still has a lot of great features. I love the way that you can use test cases. It's just so easy. So yeah, I it's just my preference.
We have like small wars between NUnit and XUnit in C#.
Yes, there are. There was a tweet just last week saying, why does anyone use anything other than XUnit? And I'm like, choice is a good thing, but no one ever likes to use Microsoft testing, like Test Suite. We use the framework underneath, but we set NUnit or XUnit on top. So
it's good to know that these kind of wars are not, unique to Java world.
No, we have our fair share of hills that people die on.
Yeah. All right. We talked about DBs, HTTP. What else? Dependency injection, right? But this was sort of one application, or maybe talking to another one via HTTP. What about an entire distributed system? If I want to have service discovery, health checks, etc., etc., what would you recommend?
So, for you coming from Spring, I would definitely say check out the Steel Toe project because it was built off Spring Boot, hence Steel Toe. And so it has a lot of the functionality that you as a Spring developer would be familiar with. Yes, the code is public. I will drop you the link right now. It's not documented. It's just my code. You'll have to deal with it, I'm afraid.
The third name makes total sense to me.
But other one that does testing for unit scopes library helper unit.
It's super descriptive.
Yeah, it's great. Yeah. Naming things, huh? So this is definitely something that you as a Java and Spring developer, you're going to feel some familiarity in here. I am actually going to show you how quick we can do service discovery. It's fun to do, and it's kind of a bit of magic. Is there a diagram for that? I don't remember. Yes, there we go.
So I like to think about
diagram.
Yes, I agree. I like to think about service discovery as a sort of a phone book. If I want to call my mother, I don't remember her name. I remember her name, hopefully, but I don't remember her number. This is what I wanted to say, right? I remember her name. I hope she's not watching, and I hope that that's not going to be on YouTube. All right? She doesn't speak English, so I'm safe. I'm safe. All right. So I don't remember her number, but still I can call her because I have a contact app. So I guess same principle can be applied. You're still laughing, right? The same principle can be applied to distributed world. When I want to call a service, I know its logical name, but I don't know its physical address. The logical name can be deployed in 3 different places because I have 3 instances for scalability reasons and so on and so forth, right? So what I want to do is I want my contact app, in this metaphor, the discovery client. Hey, what's the physical address of, risk management system? Here are the 3 instances, pick one if I support client-side load balancing, right? So this is what service discovery is. In a nutshell, how to do that in C#? Tell me.
Alrighty, so we're going to use Steel Toe. And if you remember that big old XML file we looked at earlier, let me open that. I have added 2 libraries, steeltoe.common and steeltoe.discovery.eureka. We're going to use Eureka as our service discovery. It's an open source project from Netflix or AWS or something. He's like the diagram king.
Yeah.
Yeah, you want to rethink that about those slides, okay? Go look at Jakob's old slides. Diagram king.
Thank you, Nick, the first one. I agree with you.
Yeah. Not winning yourself any friends here. I can add this just as a collection of services to my service collection, just by going add discovery client. I can then add some stuff into my app settings, which is a URL. That is the URL of this project. And then there is a whole host of settings that you can find on the Steel Toe website. But the most basic one is I'm going to say, yeah, this should register with Eureka. If you had something that was only consuming and didn't need to be found, you would put, it doesn't need to register, but it wants to go and look at it. So we're going to say it should register.
Yep.
Now I have an image already running in Docker. This is my Steel Toe OSS Eureka service. And if I can find where I put it, somewhere I have, yes, I have, this is the sort of window into my container. And you can see I don't have any instances registered on Eureka. So if I actually come here and add that bit of middleware there, I am also going to come down here and show you how we can go and consume those services. If we look at this file here, I'm using that discovery client again, which I'm getting from the service provider, and I'm telling it, can you go and get me all the applications that are registered? And then I'm going to print those to the screen. So we'll see if we get this all done properly.
Cool.
So let's run. Fingers crossed. It hasn't exceptioned yet, so this is good. You can see I've got that API there, show registered apps, but let's go look at that Eureka portal first. So straight away, you can see down here, I've got localhost, and it's given me a name, basicsforexperts.web, which was the namespace. It took that as a default. No, someone gave me that image, magically gave me the image. I didn't do anything. I got given it. And it's on that port 7038. So now, if someone asks for that basic4experts.web, it's going to tell me to go here. Okay, it's going to handle it. And now we can make sure that it's registered because I can call this, I can try it out. And if we come down here, it went and said, it went up to Eureka and said, hey, can you give me all the apps that are registered for you? And it sent this back. So that would be really cool. I have a whole blog post on Eureka and Eureka with YARP, which we've got a talk on YARP in about an hour as well. So
okay.
Yeah.
Can you show me the configuration file one more time? I have a question.
Of course.
Because I haven't seen the name of the service. I mean, the name I'm registering with. The default is the name of the project.
Yes.
Right? Basicsforexpert.web. I can, of course, rename that, right?
Yes. So there should be a whole load of different things that you can put in here. And I assume that one of those is going to be the project name. So on the Steel Toe site, there is a big, huge list of all the configuration that you can want for your Eureka. Nice.
All right. That was good. We have 2 minutes.
Wowzers. Yay. We did it.
I've done a lot. Thank you for that. That was